All right. So today we will be tackling um, subnetting. It's said to be one of the most important. Um, it's one of the most important. So what's the CC? The CCNA. All right. All right. All right, guys. Let's just get more into it. Okay. I haven't done much this whole time. Oh my gosh. Mm. distractions everywhere. All right.
Of our host addresses away and give them to the network portion of the address. When we do subnetting, the line always moves to the right. And the further to the right we go, the more subnets that we're going to have, but the less the amount of hosts that we'll have on each subnet.
Okay.
To calculate the number of available subnets that we're going to get by moving the line to the right, further over to the right. So we're going to take some of our host addresses away and give them to the network portion of the address. When we do subnetting, the line always moves to the right. And the further to the right we go, the more subnets that we're going to have, but the less the amount of hosts that we'll have on each subnet. To calculate the number of available subnets that we're going to get by moving the line to the right, we use a formula of 2 to the power of subnet bits. Now, the first time I saw this, I thought, oh, I don't know how to do to the power of, never really covered that in school much. Don't worry, it's super simple, as you'll see as we go through these next few lectures. So if a Class C network uses a /28 subnet mask, then we've borrowed 4 bits from the default of 24. Okay, normal Class C mask is a /24. If we change that to a /28, the difference between 24 and 28 is 4. The way we calculate how many subnets we're going to get by doing that is it's 2 times 2 to the power of the amount of subnet bits that we borrowed. So we borrowed 4 bits for the network portion from the host portion. To see how many networks we're going to get, it's 2 to the power of 4. To calculate this, it's dead easy. You can do it on your fingers. You start off with 2 and you just double. So I go 2, 4, 8, 16. I'm going to now have 16 available subnets. Another example, if a Class B network uses the same /28 subnet mask, well, the default for a Class B is /16. So if we subnet that to a /28, we've borrowed 12 bits. To see how many subnets we're going to get, it is going to be 2 to the power of 12. So let's do this one. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096 subnets. For that one, you might have noticed it's easy if you remember that 2 to the power of 10 is 1024. Here, we just keep doubling each time. And remember that hosts on different subnets need to go via a router if they want to communicate with each other. That's the whole point of having our IP addressing and of doing subnetting. It's to divide our network up into different logical parts of the network, and it's the routers that are the device that know how to get everywhere and that can direct the traffic. Okay, so that was how to calculate the number of subnets we're going to get. It's 2 to the power of how many bits that we borrowed. To calculate the number of hosts, it's 2 to the 6 subnets. For that one, you might have noticed it's easy if you remember that 2 to the power of 10 is 1024. Here, we just keep Keep doubling each time.
Good.
And remember that hosts on different subnets need to go via a router if they want to communicate with each other. That's the whole point of having our IP addressing and of doing subnetting. It's to divide our network up.
What do we need to borrow? Okay, it's 2 to the power of subnet bits. So if a class B network uses a 28 subnet mask, then we've borrowed 12 bit from the default of 16. Okay, so it depends on how much you use. So let's say if a class B network uses a destination of subnet, how much gets it borrowed? Okay, so here, if a class B subnet uses, if a class B network uses a 24 subnet mask, how many bits has it borrowed from the default -16? If a class B network default 16 uses a 24 subnet mask, borrowed 8 bits from the host to create subnets, resulting in 8 times 2 times 8 of 256 subnet. But the question has a slight contradiction, as a class B default is /16, not 26. Come on, you know what I meant. Okay. The 16, the new subnet is lower. The difference between is only plus 8 4. Of course, I know that. Come on, let's dive deep into it with AI. Okay, the difference. Okay, what's the significance of borrowing? Show me an example, class B. The sub B. Yeah, show me. Let's see. Okay, an example sub B IP address is 1 with a subnet mask of IP.1. This is default addresses because first octet 172 is the default class range of 128 to 190 to 191. Also within the private IP address range for class B networks, which is okay, subnet mask. Okay, network usable host range will be from 176.16.5 to 176.2 broadcast. So how many IP will be able to be used? Will be available to be used, not able to be used. The total of addresses will be 2 times 8 will be, which is 256. So from 0 256 isn't Wait. Addresses leaves 256, 54. Yeah, 254. Yeah, not 256. It will be 254. Okay, what are other ways I can practice this to understand it better? Okay. All right. We're just gonna take more and more notes, and the more as we practice and do it, I think that's how the more we're going to
Into
understand it.
different logical parts of the network, and it's the routers that are the device that know how to get everywhere and that can direct.
So the best way is to like understand what you need, right? So you first have to understand which type of class will I need. Is my network a small, is it large, or is it medium? And then from that you can decide, okay, if it's a big company and we have a lot of devices, I will probably need a class B since that's the largest. So then we go to class B, and then the class B default subnets will be /16. And then okay, network uses a /28 subnet mask. So then how do we know which subnet mask to use? You know, that's also another question. Okay.
The traffic. Okay, so that was how to calculate the number of subnets we're going to get. It's 2 to the power of how many bits that we borrowed. To calculate the number of hosts, it's 2 to the power of how many host bits there are.
Okay, so that's that. Now to calculate the number of hosts. To the power of host bits minus 2. So we're just gonna use class C again. If class C, a class C host network uses a /28 subnet mask. Then 28, 16, it's like 12. We have 4 bits. So the thing with this is, so that's also a number of hosts. Okay,
are minus 2.
2.
We need to subtract 2 because we've got the network address and the broadcast
16.
address that cannot
16
be assigned
minus.
to hosts. That's the 2 that we take away. So if a Class C
It's a
network
Class
uses
C,
a /28
so
subnet
24.
mask, then we've got
28
4 bits
minus
left for
24,
hosts.
that's
There's
4.
32 bits in the address. If we're using 28 for the network portion, that leaves 4 for the host portion. 2 to the power of 4 is 2, 4, 8, 16, minus 2 for the network address and the broadcast address. That means that we would have 14 available addresses for our hosts. If we've got a Class B network and it's using a /28, again, we've got 4 bits left for our hosts. So 2, 4, 8, 16 minus 2 is 14. It's exactly the same. So notice that the amount of hosts we're going to get is going to be dependent on the subnet size, and it's going to be the subnet mask size. It's going to be the same whether it's Class A, Class B, or Class C. But the amount of subnets we'll get, if I go back a slide, it's going to be different for Class A, B, or C because they've got different default subnet mask sizes. For example, if we use a /28 with a Class B, then we're going to have 4,096 available subnets. If we use a /28 with a Class C, we're going to have 16 available subnets. There's a difference there. But for the hosts, it's always going to be the same. Okay, a quick note on IP subnet 0 command. Just like we have to subtract 2 to get the number of valid hosts, back in the day, we used to also have to subtract 2 from the number of available networks. This is because in the original...
All right.
Okay, moving on, let's say that we've been allocated Class C 200.15.10.0/24, again the same as the last example, and here we're going to move the line all the way to the right. We're going to go with a /31. Obviously we can't do a /32 if we want to have more than one available host now. You can use a /32 subnet mask, but there's only one host there. That's mostly used for loopback addresses. Don't worry about it yet, we're going to talk about that later on. So if you do need to have multiple hosts, then the furthest right you can go is a /31. If we wrote that subnet mask in dotted decimal notation, it would be 255.255.255.254. We get the 254 because it's 128 plus 64, 32, 16, 8, 4 plus 2 comes up to 254. So that leaves 1 bit for the host address, which has obviously got a possible value of a 1 or a 0. So a Class C, a /31, it borrows 7 bits for the network address from the host address. That gives us 128 subnets, which is 2 to the power of 7. Again, let's count it up. 2, 4, 8, 16, 32, 64, 128. And that's going to accommodate 2 hosts each. So that's what we get with a /31. The valid host addresses would be 200.15.10.0 to .1, 200.15.10.2 to .3, then 200.15.10.4 to .5, etc., all the way up to 200.15.10.254 and 255. You can check this by, we're using 200.15.10, so the first 3 octets are never going to change. The last octet, you just start with all zeros, and then it would be 0000001, and then a 0 or a 1, and then 0000010, and then a 0 or a 1, and so on. Okay, but wait. If we're using a /31, there's only 2 possible values to assign to hosts. What about the network and broadcast address? Yeah, a /31 subnet breaks the standard rules of IP addressing, where we have to have the network address and the broadcast address at the top and the bottom of the range. /31 subnets are, however, supported on Cisco routers for point-to-point links. If you think about it, a point-to-point link, there's just one can have a /31 on a point-to-point link. Okay, next up, moving on, we're going to move the line back a space. We're going to create a /30 now. The subnet mask in dotted decimal, 255.255.255.252, that and /30, they both mean the same thing. That is going to leave 2 bits. For the host address, because we got 2 bits for the host address. 2 to the power of 2 is 4 minus 2 for the network and the broadcast address. That gives us 2 possible hosts. It borrows 6 bits for the network address. If we count this up, 2, 4, 8, 16, 32, 64 is our 64 bits, which can accommodate 2 hosts each. The valid addresses are, on the first subnet, the network address is 200.15.10.0 and the broadcast address is 200.15.10.3. The valid addresses are .1 and .2. The next subnet is 200.15.10.5 to .6, and the network is .4, the broadcast is .7. The next subnet, the network would be .8, the valid addresses would be 9 and 10, and the broadcast would be .11, and so on. Okay, as you look at this, the way that you can calculate what the different valid subnets are going to be, notice where the line is, it's after the number 4. So the network address is going to go up in values at 4. The first network address is .0, the next network address is .4, the next network address is .8, .12, .16, and so on. And because we know the network addresses, we can work out what the broadcast address and the range of valid IP addresses are going to be. So here it's going up in values of 4. The first subnet is going to be a 0. So 0 is the network address, and because the next range starts at .4, the broadcast address must be .3. So if 0 is the network address and .3 is the broadcast address, the valid host addresses must be .1 and .2. The next subnet, it starts with 4. The next subnet after that is at .8, so the broadcast address must be .7. So network address of .4, broadcast address of .7, that leaves the addresses in between of .5 and .6 are available to be assigned to our hosts. Okay, let's look at a comparison between the /31 and the /30 now. Hopefully you noticed that they both supported 2 hosts per subnet, but a /31 supported 128 subnetworks. A /30 only supported 64. So you're maybe thinking, oh, well, we're always going to use /31 then. And a /31 is useful if you need to maximize the use of your address space. But a /30 is more commonly used, it's more standardized. For the CCNA exam, if you get a question where you've got the choice where you could use either a /31 or a /30, always use a /30. So if the question requires you to come up with a subnet that supports 2 hosts, use a /30, unless the question explicitly tells you to use a /31. Okay, so we covered a /30 and a /31. Next up is a /29. So we're going to move the line back a space again. A /29 in dotted decimal is 255.255.255. .248. Again, we get the 248 because it's 128 plus 64 plus 32 plus 16 plus 8 up to where the line is. That leaves 3 bits for the host address. 2 to the power of 3 is 248. 8 minus 2, because of the network address and the broadcast address, gives us 6 available host addresses. And class C, the default subnet mask is 24. Here we're using a /29, so we're borrowing 5 bits for the network address. 2 to the power of 5 is 2, 4, 8, 16, 32. So we've got 32 available subnets here. The valid host addresses, notice that the line is after the 8. So the network addresses are going to go up in values of 8. The first one will be 0, then 8, then 16, and so on. So the first subnet, the network address is 0. The next subnet, the network address is 8. So the broadcast address for that first subnet must be 1 less. It's going to be 200.15.10.7 for our example. So the network address is .0 and the broadcast address is .7. That leaves
So okay. So here it was at 2. So it goes up by 1 from 0 to 1, from 2 to 3. Here's a
nets here. It's for the net.
Okay.
Network address. 2 to the power of 5 is 2, 4, 8, 16, 32. So we've got 32 available subnets here. The valid host addresses, notice that the line is after the 8, so the network addresses are going to go up in values of 8. The first one will be 0, then 8, then 16, and so on. So the first subnet, the network address is 0, the next subnet, the network address is 8, so the broadcast address for that first subnet must be one less. It's going to be 200.15.10.7 for our example. So the network address is .0 and the broadcast address is .7, that leaves .1 to 6 available to be assigned for our hosts. The next subnet is going to be, we said already, starts off with .8. The next one is at .16, so our broadcast address now must be .15, one less, which leaves
so we take out
the
two
available host addresses of .9 to .14.
take out two
We can go
addresses
on like this,
for
all the way up
network
to
and broadcast.
200.15.10.248 is the network address,
Okay.
255 the broadcast address, with host address.
Now the hard things will be how am I going to practice these by myself?
And we can carry on
I gotta find a way.
the line back a place. So we did /31, /30, /29. We could also do a /28, which is 255.255.255.240. That is going to give us 16 networks of 14 hosts each on
Sixteen networks, two for the broadcast and network, and then 14 for the hosts.
1A Class C. Again, the default is a /24. If we're using a /28, we've borrowed 4 bits. 4 bits
Okay, so
is 2, 4, 8, 60.
when the slash is not equal to the so let me ask so when the slash is not equal to the default, like /24, we borrow, right? Okay, when inside the slash notation like 24 is larger number than the borrow default mask for that class of IP address, like /16 for class B, it means you have borrowed bits from what could typically be the host portion of the address and assign them from the network. This borrow process is called subnet. Okay, so what if it's less? If the slash notation is smaller than the default mask, you are essentially doing the opposite of subnetting, which is called supernetting or route summarization. In supernetting, you are taking bits from the network portion of the address and giving them back to the host portion. Okay, so it moves bits to the right, and that moves bits to the left. Network size divides one large network into smaller ones, combines multiple smaller networks into one large one. Fewer IP addresses per network, more IP addresses per network. Better IP allocation and network management, simplifies routing and reduces router table size. Okay, I just had to go on that side quest by myself. All right.
Available subnets, and after 28 it goes up to 32, so we've got 4 bits available for our host addressing.
Yeah.
That is
So the
2,
point
4,
is
8, 16 minus 2 for the host, which gives us 14 available hosts.
Addresses, right?
The
We do this subnetting. Yeah. Divides one large network into smaller ones. Splits an IP address could be split. Dividing one large network into smaller ones. Okay. Dividing one large network into small ones. Okay, having a simple explanation like that is so good.
We can move the line back
Just
again
like
to
that.
a /27. That's going to be borrowing 3 bits, so that is 248 available networks, leaving 5 bits available for our hosts.
/27.
2, 4, 8, 16, 32.
That's gonna be
minus 2 gives us 30 available.
Or 255.255.255.224. That's also something that I gotta learn or keep in mind. That's something that I also gotta keep in mind.
You can see how I'm getting that now.
Like if you are
/26 is
26.
4 networks and 6.
Okay, so if it's 26, 26, that means from 24 we'll be borrowing like 2 networks. 26, 24, yeah, that's 2, isn't it? I mean 2 what are they called? 2 addresses. We'll be borrowing 2 addresses from the default 24. For 16, so will that be 240 minus 16? Okay, 222 minus 16. Is it 6 data 2? Yeah, 1. Yeah, that is it. I don't know why I had to pull up the calculator, but 224 minus 16, 208. Okay, maybe it's minus 24. 224 minus 24, it's 200. 27. 224 minus 26. Where did that 192 come from? Okay. Okay, my question now is, now this is how you learn, by asking the questions. So in this, okay, from this, why did it go from 255.255.255.224 to then 255.255.292 for the /26? How do we know? Sorry, only ChatGPT can answer me this question. Okay, this subnet mask release state appears to contain a typo that is correct to be 255.192. Oh my gosh. Yes, it has a typo. Okay, IP address. Okay, how know the correct value? Okay, subnet mask file changes specific increment based on the power of 2 because each increase in prefix number /24/26, for example, removes 1 bit from each network portion, adds it to the next portion the value. Okay, so /28 is 240, leaves 4 bits for hosts and 16 for hosts and 16 hosts total, 14 usable, 30 usable. Yeah, I know that. Okay, so turn on. So the number in the last octet, 240, are determined by which bits are turned on. Set to 1 in binary represents, so the value /26 for instance has 2 network bits turned on in the last octet, which is decimal for 128 plus 60 plus 64. Okay, hold on. Just the last octet, right? Is what we're looking for. Is what we're saying. Okay. So slash the value slash 126. We take the default is 2. Yeah, has 2 bits. The default is 24, so we take 2 bits. 2 bits to make it 26. So that would be like over here. So we turn off 2. We turn for it has 2 bits turned on the last octet. So these last octets, 2 bits are turned on. These ones. Okay. So for 24, for 27, that will be how many? 3 from 24. Yeah, that would be 3. What if it was /27? If it was /27, we already see what it will be. Corresponding to the 224 network configuration left number 224 masks 27 bits are used for the network portion and 5 bits are left for the hosts. And 5 bits are left for the host portion. 32 and 30 in IPv 27 bits equals 5 bits. Using the 5 bits, you can calculate the available. Maybe in class C. Yeah. See, in class C will be 3 bits. 2 times 32, and then bits per subnet. Okay. Where did the 5 come from? Has a total of 32 bits. The subnet determine how 32 bits are. Okay, so 32 minus 27 it is then. 32 minus 27. It should be give us 5. 32 bits minus 27. Yeah, and then that will be 5 host bits. There are 5 host bits, and so for a subnet, that'll be 2 to the 5 equals 32 addresses, 30 usable hosts. Okay. Sometimes I like confusing
16.
myself
And back
to understand
again
more.
to /27, that's going to be borrowing 3 bits, so that is 248 available networks, leaving 5 bit. A /26 is 4 networks and 62 hosts. A /25
/25 is so it increases. It increases. this increases, the number increases, and this decreases. Okay, so that's, you will only be borrowing 2. So that would be 32 minus 25. 32 minus 25, that's 7. I confused myself, so
is 2 networks and 126 hosts, and /24 is the default 1 network with 200
which is the default. So I feel like I will understand it more. 254 hosts. Okay, I feel like I will understand it more if I go from this and going increase, 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 and increase. You only have like 32 bits, so it can go up to 31. So 0, 154 hosts. Go to the next one is 126.
54 hosts. Okay, so that's how we carry out subnetting and figure out how many networks and how many hosts we're going to have. Next thing to tell you about is variable length subnet masks. With early routing protocols like RIP version 1, they only supported fixed length subnet masks, which meant you could subnet, but all subnets in a particular network had to be the same size. So all of your different subnets had to accommodate 14 hosts, for example, or 30 hosts, for example. And if you had one subnet that needed up to 30 hosts, you had to have all your subnets at a size of 30 hosts, even if one of them only had 3 hosts in it. Then, with later routing protocols, they came out with support for variable length subnet masks. That means that within the same range, you can have different sizes of subnets in there. So say I've got one part of my network which has got 10 hosts in it, I could give them 14 available hosts, and another part of a network that's got 28 hosts there, I could give them a subnet mask that gives them 30 available hosts. Okay, so variable length subnet masking, it means we can use different length subnet masks within the same network. This is a good thing because it lets us be much more precise with the size of our networks, and we're going to be wasting a lot less addresses. We'll cover how to do VLSM, variable length subnet masking, in the next lecture.
I need these. I gotta practice these really.
Hopefully you've got a good handle on all of the subnetting information that we've covered so far, and you'd be able to work your way through a subnetting problem. But let's actually verify that now by doing a practice question. So the question is, what are the network address, the broadcast address, and the valid host addresses for the IP address of 198.22.45.173/26? And the second part of the question, what is the subnet mask in dotted decimal notation? So stop the video now, please, and figure that out. When you come back, I'll walk you through how we arrive at the answer.
Okay, so the question is subnet parity. So what are the network addresses, broadcast addresses, and valid host addresses for the IP address? Now that's what we need. That's all we need. Okay. Gotta be real with this though. Okay, so practice. 22. So you already know if it's 198, that means that's yeah, it's a class C network. 5, 173 over 26. Okay, so what we know is it's class C. What is subnet mask dotted? Class C default will be is 24 slash 24. It's class C, default's 24. Bits over there, so that would be 2 for the network address. That would be 2 over 24. 26 minus 24, that's 2 over 2. So 2 over 2 to the power of 2, that's 4. For broadcast, that would be 2 over 2 minus 2, which will be 4 minus 2, which is 2. Now the problem is, so that's 24, that means it's basically like it's 255.255.254. No, that 251, that 2, that's last octet. Last octet is what I have an issue with. Last octet. If that was 254, because we gotta have, I mean, like from 255 we gotta have like 254, we gotta have one for broadcast address. Oh. That's how far I could go. Okay, that's how far I could go right now. That's how far I could go. For an answer, that is how far I can go. Whatever that's written over there, that's how far I can go right now. Let me see if I can. Let's see what the answer is. That's the first one.
Okay, so let's look at how we are going to figure out the answer to.
Okay, so we borrowed 2 in the last octet. Okay, we know that. So let's figure out the subnet mask in dotted decimal. That, so since we borrowed, oh, that's how it is. So you will take from the 128, so from this we borrowed 2. Let me stop playing one. So we borrowed, come on, we borrowed these 2, so that's 128 plus 264. So find the last octet. So 128 plus 64, which should be to 192. So that would be 2555 190. Would be not 92 or 94. 94. So subnet mask is okay. We got the subnet mask, and since we figure out that we will need to borrow 2, we borrowed from that. Okay, and this will be used for host, I believe. My gosh, these markers, they smell bad. Like, they smell bad. I feel like I'm gonna get sick from this smell. Ugh.
The question. We're actually going to do the second part of the question first because it's more logical and easier to do it that way. So the second part of the question was, what is the subnet mask /26 in dotted decimal. And the way to do this, whenever you're working out a subnetting problem, particularly at the start, is to write out the bit pattern at the top of a piece of paper. Now later on, you'll be able to do a lot of these in your head.
Okay, so write the bit pattern. So note. This is why you need 3 different colors. Write the bit pattern. Down here. So we have to like transform this into the bit. So maybe if we are able to like transform this into binary, and then that way it could be well, I have mine over here. So 198. We don't need that. We just, I think the last part is like we use 198 to identify which class it is, so we can know the default for that class. Okay, and then the last octet 173 is what we really need to know. 173 /26 suffer from 26. We know that we need 2, so we do that. We take these 2. Okay, 173 128 173 minus 128. Let me see. 128. No, not 128. Okay, so 173 minus 128. That will leave us with like, oof, my gosh. Near 1, so that is 13 minus 8. Shoot. It would leave us with like 62. 62. 45. It's 45. Well, so then that would be, so this would be 1, that would be 0, 45, that would be 1. So then that would be 45 minus 32. That will give us 13. So the next one will be 0, and then a 1. 13 minus 8. That will give us like, what was it? 5. Yeah. No. Yeah. That will give us 5. And then that's also 1, then that's 0, then that's 1. So that would be 1 0 1 0 1 1 0 1.
But when you're first learning, it's way easier to write it all out like this. So take a piece of paper, start off, and at the top, start off at the right and write 1 2 4 8 16 32 64 128. And then you can put a dot in, and then 1 2 4 8 and so on, until you've drawn out the bit pattern for the 4 octets in your subnet mask. Then
so you do that, the bit for Okay. Okay, I see why. Because once you have all of it, well, once you have like all of it, this whole line, right? Once you have this whole line, once you come down here, since you need two, you will turn on these two and leave everything else. Oh.
The question that we had was we had to work out the dotted decimal notation for a /26. So just under your bit pattern at the top of the paper, write out 26 ones underneath that, and then you can put in 6 O's for the host portion of the address. Also draw a line in where the line is for the subnet mask, and then we can just add these up. So obviously the first octet is all ones, it's going to be 255. The second octet is also going to be 255. The third octet is also 255. And then at the fourth octet, where we're doing the subnetting here, the ones are in the 128 and the 64. So we add 128 and 64 together to give us 192. So a /26 in dotted decimal notation is 255.255.255.192.
So that's the subnet. So this is subnet.
Okay, let's look at what the second part of the question was. What is the network address, the broadcast address, and a valid host address for the IP address 198.22.45.173/26? So again, we use our piece of paper and we're going to write out the IP address now as well. You can see that I've done it on the top part here. That is the bit pattern for 198.22.
101.01101.1.
That's how we would write it in decimal. And the network portion of the address is the first 26 bits. So I can see that that is 198.22.45, and then I just count whatever is in the first 2 bits here, and I've got a 1 for the 128 and a 0 for...
Oh, so that's what you do for the network address. So for network address, okay, understandable. So for the network address, it goes the same as the given address that we were given. So like 198.22.45, and the last octet is the different one. It's the different maker, and it's 128. And you ask yourself, how did you get 128? And so that comes from that. Remember, we need to borrow, or we need to take, just borrow 2, right? So from the 173, we take only this. Which is 128 plus 64. What did I write? No, it's not plus 64. It's plus 0. Sorry. 164 plus 0. 168 plus 0. And that's this number right here. Okay. This 192 came from that. So I'm also going to that here, just to differentiate. So this is how we got that. So for the network address, we did not include the 0, but for the subnet we included the 0. which are like the subnet. So these are supposed to have their own octets, like octets rows.
Of a 64, so that means it's 128. So the network address is 198.22.45.128. Don't worry about the text yet, by the way. This is a second way that we can figure out the answer that I'll get to in a second. I'm going to explain how to do it the long way first. So the long way is the logical way to do it at first. Again, we write out the IP address and the subnet mask in binary notation, and we put in the line where the subnet mask is. From that, we can figure out what the network address is. Like I just said, 198.22.45.128, I can see it here. Then we figure out what the broadcast address is. So that would be if we had a 1 in all of the host bits. So that would be a 1 on the 32 up to the 1. And if we add up 32 plus 16 plus 8 plus 4 plus 2 plus 1. Okay, that's 32 plus 16 is 4. 48, plus 8 is 56, plus 4 is 60, plus 2, 62, plus 1 is 63. So the network portion of the address was .128. 128 plus 63 is going to be 191. So again, the network address is 192.22.4.
So we got that 191 by, so after the number is 64, by adding, I'm just gonna do black. So by adding, after the 64, by adding 32 plus 16 plus 8 plus 4 plus 2 plus 1, which was equals to 63, as he said. Right.
Plus 4 is 60, plus 2, 62, plus 1 is 63. So the network portion of the address was .128. 128 plus 63 is going to be 191. So again, the network address is 192.22.45.128. The broadcast address is 198.22.45.191. So we've got the network address and the broadcast address. The possible host addresses are going to be the addresses that lie between those two numbers. So that would be...
So speaking subnet. Okay, so since we only wanted these two, the numbers after 64. The numbers after 64 added by the last network address. Added to the last net address or octet. Yeah, and then the possible hosts, possible hosts goes from 129 198.22.45.129 to 198.22.45.190. Okay, and the relationships is this and facts.
The 198.22.45.129 going up to 198.22.45.190. Okay, so that's how we can figure it out very manually and very logically. We can take a little bit of a shortcut, and what we do is, again, you saw this in the last lecture, we look at where the line is. So the line is here after the 64, so I know that my subnets go up in multiples of 64. So the first one is going to be 198.22.45.0, then 45.64, then .128, and so on. I can see that this address that I'm interested in is 198.22.45.173. So first subnet is 0, then 64, then 128. The next one would be 128 plus 64, which is going to be 192. So this is less, 173 is less than the 192, so it must be in the 128 network. Okay, so I know this is in the network 198.22.45.128. I then add on 64. I know to add on 64 because that's where the line is, and the next network address would be 192. So if the next network address is 192, it must mean that the broadcast address for this subnet is one less than that. It's going to be 191. So there, I've figured out my network address is 128. I figured out that my broadcast address is 191. The available hosts must be everything in between. That would be 198.22.45.129 to 198.22.45.190. Okay, so that is how we can figure it out. And a final important point to tell you here is, notice that everything was done on where the subnet line is. And this example is /26, so that is in the last octet. So we don't actually need to worry about the first 3 octets. They're always going to be unchanged as 198.22.45 in our example. So you can save some time by only writing out the octet that the subnetting is happening on. You don't have to write the whole thing out in full every time. Okay, so that was a quick example of how we will solve a
Focus on the last octet when subnetting.
so
Okay, I wanna. I want to copy this. Alright? Just to leave it there, just so we know it's shortcut.
in this lecture, we're going to carry on with our subnetting theme, and by the end of the lecture, you will be able to carry out a variable length subnet mask design for a real-world network topology. Now, it's only a small network in the example that we're going to work through, but you can apply the same things that you're going to learn here to larger networks in the real world. The slide that you see here is the same slide that you saw at the end of the last lecture, where we explained that back in the day with early routing protocols, whenever you did subnetting, each of the subnets had to be exactly the same size. So if you had one subnet that was a /28, for example, they all had to be a /28. You couldn't mix and match /27, /28, /29 within the same larger network. But that ended up wasting a lot of addresses, so with later routing protocols, they did have support for variable length subnet masks, and now we can mix and match the size of our subnets within that greater network. And we're going to work through an example here. The things that we need to consider when we're going to do the design are how many different locations do we have in the network that are going to need subnets, and how many hosts are going to be in each of those subnets. What are the IP addressing requirements for each of the different locations? So should different departments or types of hosts be in different subnets? For example, you might have one office, but within that office, maybe you've got a sales department, a research and development department, and an accounting department, and you want the accounting department to be secured from different departments. Well, in that case, you would definitely put it in its own separate subnet. Because different subnets, we have to route between them at a router, it's easy to secure them at the layer 3 level based on their IP address. And the last question here, what size is appropriate for each subnet? We don't want to waste addresses, but we want to leave some room for growth. So we need to have a bit of a balance here. Don't make it too big, we're wasting addresses, but don't make it too small that we're going to run out of addresses and then going to have to do a redesign later. That would just be giving ourselves a big headache. So for our example, this is our network topology diagram. We've got an organization, they've got an office in New York and a branch office in Boston. New York is their headquarters, and they've got 28 hosts in the engineering department and 14 hosts in sales. In Boston, they've also got engineering and sales. They've got 28 in engineering, the same as in New York, and they've only got 7 hosts in the sales department. So those are the different parts of the network that we need to apply IP addresses to, and we've been allocated the class C network of 200.15.10.0/24 too small that we're going to run out of addresses and then going to have to do a redesign later. That would just be giving ourselves a big headache. So for our example, this is our network topology diagram. We've got an organization, they've got an office in New York and a branch office in Boston. New York is their headquarters, and they've got 28 hosts in the engineering department and 14 hosts in sales. In Boston, they've also got engineering and sales. They've got 28 in engineering, the same as in New York, and they've only got 7 hosts in the sales department. So those are the different parts of the network that we need to apply IP addresses to, and we've been allocated the class C network of 200.15.10.0/24 from our internet service provider. Another thing that we need to do is don't forget about our point-to-point links between the routers. They need to have connectivity between each other, so they're going to need IP addresses too. It's a point-to-point link, so we've just got two host IP addresses there. The outside interface on the New York router is connected to the outside interface on the Boston router. So that was our requirements. So now we need to think about how are we actually going to design this. And the steps that you work through. First off, find the largest segment and allocate a suitable subnet size for it. You then create that subnet at the start of your available address space. And then that's it. You just keep working your way down. So you start off with the largest subnet, you then move to the next one, the next one, and the next one until you've allocated addresses for all of your different subnets. Now, in a real world deployment, you want to have a scalable design. So you want to have room for growth in your networking design. So let's say that I've got a subnet that has got 14 hosts on there. Well, you know that one of our subnet sizes is exactly for 14 hosts. Don't give the subnet that size, because maybe in a few weeks' time, a couple of extra people are going to join the department, and now how are you going to fix that problem? So make the subnet size big enough that it's going to be able to grow. Another thing is, because we're going to sequentially go from largest down to smallest, maybe we're going to have a subnet with 30 hosts there, and then another subnet with 30 hosts, and then a subnet with 14 hosts. Well, leave a spare subnet with 30 hosts in it. So don't just do 2 subnets of 30, do 3 or 4 subnets of 30. Because then if you do have a new department that requires up to 30 hosts later, you've got a spare subnet there waiting for it, and everything is still sequential and contiguous and logical, going from largest down to smallest. Okay, so hopefully you got the point there. Don't design for what is right now. Design for what is going to be the best fit in the future. Leave some scalability there, leave some room for growth. So that's what you do in the real world. Don't do that in the CCNA exam. Okay, do not think about, oh, this is what I would do in the real world, this would be best practice. Do exactly what the exam question tells you to do, even if you think that would be a stupid thing to do. Okay, don't overthink things. Don't think, oh, well, it would be better to do it this way. Do exactly black and white what the question asks you to do.
That's
and
funny.
then you're going to get the question right. Okay, so for our example, we had the engineering departments in New York and Boston, and they have got 28 hosts each. And that was the largest subnets that we required. For our example, let's say the exam question says that the departments will not grow and we need to use the smallest subnets possible to maximize our available address space. Okay, so do not leave any room for future growth here, because the question says make it optimal. Maximize the use of the address space. Okay, so that's the question. What I want you to now is pause the video here and calculate the optimal subnet mask for the engineering departments. So no bigger than is necessary, but make sure it's at least big enough to support 28 hosts. Once you've done that, you'll be able to determine the network and broadcast addresses. Do that for both engineering departments, both New York and Boston, and figure out what the range of host addresses will be. Okay, so go on ahead and do that. Please pause the video now. When you come back in a second, I'll walk you through how to get the answer. Addresses will be.
Okay, so I gotta design that. I'm gonna be like I forgot it, I don't know his full name. So sketch. Do I have anything to sketch? Maybe on notepad. No. Paint. Yeah. Paint. Okay. Let's see. Brushes. No. Okay. Okay, so the engineering wants 28 hosts. All right, so that would be E wants 28. Now my drawing is really bad. Now I cannot do it digitally. Way too bad. Way messy. It could get messy. Yeah, I can just do the example down here. We don't need all of this. Don't need that. It's like I haven't memorized it yet, so I will need that to stay there. I also want this example to stay here too. So next. Okay, so engineering department said they will only have 2. Okay. Engine, they'll only have 28 hosts. So 28 devices. For engineering department on both sides, 28. Both sides have 28 hosts. So that's 28 times 2. So it will be okay. Engineering 1 will need to have engineering 1 and 2. So engine 1 plus 28. Engine 2 plus 28 too. So we'll have a total of how many? 50 watts. 56? No, that's not divisible by 2. 58? No. Maybe 62. We'll have a total of 62, I think. 56. Okay, I was correct. We have a total of 56. Being told that the department will not grow and will need to use smallest subnet possible to maximize. So if they want to use the smallest possible, now the question is, do they want it? Will we want to use a public or private? So if they want the slowest possible, yeah. Oh my gosh. So this is how the real world works like, huh? Okay. Optimal subnet mask. Um gosh. Okay, so I guess 192.50.20. That does it go over? That means this is just gonna be for one of them. That 28, that 29, since we need, or maybe that 30, because we need to have two, 26, two more. That's 26. Then in 28, so that'd be like that 30. I'm sorry, y'all. I don't know that 30. I do not know. I don't even know how to know. I don't know how to go about it. So let's see
Okay,
what
so
this guy
go on
does
ahead
first.
and do that. Please pause the video now. When you come back in a second, I'll walk you through how to get the answer.
Okay.
Okay, so let's look at how to get the answer.
We've
So we've been
allocated.
allocated 200.15.10.0/24. We've been allocated a class C. And we've got two different departments that we want two different subnets for,
Yeah.
and they had got 28 hosts each. A
Okay.
/27 supports 30 hosts.
Okay. So /20. So it's okay. That's good to know. That's good to know. So /27 supports 30. That's a good thing to have, like, in mind. It's something to have in mind. It's a good thing to just have in mind, just like that. So that's /27 supports up to 30 hosts, and /26 supports up to 62 hosts. Because /24 supports up to 254. 254 minus 62, 64, was it? No. T, 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 T. Okay. Okay. Okay.
28 is 14, so it's not big enough. We can't use that. The smallest that we can use, which is what we were asked to do, is a /27.
Yeah.
Real world, you might argue that you'd prefer to use a /26. This is not the real world, it's an exam question. We're going to use the smallest possible, which was a /27. We wrote that in dotted decimal notation. It's 255.255.255.224. Okay, so that was the first part of the question, figure out the subnet mask. The next thing we have to do is actually divide up our address space. The headquarters was in New York, so let's give them the first subnet. So the network address is going to be 200.15.10.0/27. And if we look
Okay,
at
and I guess they'll both have to be on the same network. I mean, on the same, like, addresses, in order to to make things work. I was thinking of two different things. Like, this was supposed to only just be for the engineering one, but you're supposed, okay, so in a total they're supposed to have 27. Okay, I thought it was 27, 28 each. Okay, maybe that's something to keep in mind when you're doing the
we
test.
can see it's after 32, so a /27 is going to go up in increments of 32. So the next network address is going to be 200.15.10.32, which means that the first subnet's broadcast address is going to be one less than that. It's going to be 200.15.10.31. And that leaves addresses available for our hosts of 200.15.10.1 up to 30. Okay, so that's the engineering subnet. Next is the Boston engineering subnet. Well, the last broadcast address used was .31, so the network address we're going to be using is .32. So network address 200.15.10.32/27. Again, we're still using that /27, where the line is after the 32. So the next network address would be .64. So our broadcast address must be 200.15.10.63, which is one less, and our hosts are going to be what's between the network and broadcast address. That's 200.15.10.33 up to 62. Okay, so that was the engineering department's taken care of. All right, that's coming up to the 10 minutes.
I guess that's good to know. I guess that was good to know, but the way that it actually works is kind of like different. It's nice to know. It's nice to know. It's nice to know. It's freaking nice to know. Okay, so I'm just gonna do this right. And that's just one part from what that's just one part. That's just the engineering, and we've got to do engineering, and then sales also. 28 hosts, 14 hosts.
200.15. The next largest subnet is New York sales, which requires 14 hosts. So I want you to pause the video again here, calculate the optimal subnet mask for New York sales, and again determine the network and broadcast addresses and the range of available host addresses. Okay, so stop the video now. I'll see you in a second once you've worked that out. Okay, so let's look at the answer. We need to support 14 hosts. The smallest possible subnet we can use is a /28. /28 means we've got 4 bits available for host addresses. So that's 24816 minus 2, that gives us the 14 hosts. 200.15.10.0 to 200.15.10.63 were already being used by the engineering department. So the network address that we'll start with here is 200.15.10.64. If we look at the line, we can see it's after the 16. So 64 plus 16 is .AA. Take one away, our broadcast address is going to be 200.15.10.79, and the available host addresses 200.15.10.65 to 200.15.10.78, the addresses that are between the network address and the broadcast address. Okay, that's our first 3 departments done. The last department was Boston Sales, which requires 7 hosts. So let's do the same thing again, calculate the optimal subnet mask, and then the network address, broadcast address, and the host address. That we're going to use. So stop the video now, and I'll see you back with the answer. Okay, so we need to support 14 hosts. We're going to use a /28 again here, the same as what we did for the last department. You can use a /29, which is a possible mistake that some people would make, because we need to support 7 hosts, so they go 248, okay, that's 3 bits, and they'll make it a /29. They forgot to take away the 2 for the network address and the broadcast address. Okay, a /29 supports 8 minus 2, 6 hosts. We require 7 here, so that's enough. So we're going to use a /28 again, which supports 14 hosts. The last broadcast address was 200.15.10.79, so our network address will be 200.15.10.80, Again, the line is after the 16, so the next network address would be not .96, which means our broadcast address is going to be 200.15.10.95. The valid host addresses are .81 to .94. Okay, so that's it. That was our 4 departments, so we're done, right? No, remember we have to allocate addresses for the point-to-point link between the routers in Boston and New York. Another thing you would do in the real world is you would also allocate address space for your loopback addresses. Loopback addresses are used for management. They're a logical address, so there's not anything physical on the other end, so we'll usually allocate a /32 to our loopback addresses. Again, we'll talk about loopback addresses more in later lectures. Don't worry about them for now, I just mentioned it here for completeness. Okay, so that last subnet, the link between the New York and Boston routers. So let's do the same thing again. Pause the video, determine the optimal subnet mask, and the network, broadcast addresses, and the host addresses that we're going to use. So pause the video, and I'll see you back with the answer. Okay, so we want to support 2 hosts. Remember, a /31 or a /30 supports 2 hosts. And hopefully you remember I told you before, unless the exam explicitly tells you if you need to support 2 hosts, go with a /30 because that's a standard that we use. It complies with all of the internet standards. So we're going to use a /30 here for our 2 hosts. We're already using up to 200.15.10.95 for our departments. So our network address will be 1 up from there. We're going to use 200.15.10.96. If you look at the line, it's after the 4, so the network address is going to go up in increments of 4. So the next network address would be 200.15.10.100. 1 less than that gives us our broadcast of 200.15.10.99, which leaves the host addresses to be .97 and .98. Okay, one more thing that I want you to do. I want you to have a look again at the network topology diagram that you saw at the start of this lecture. You don't need to scroll back, I'm going to put it up on the next slide. Then what I want you to do is get a piece of paper and a pencil, and I want you to draw the network diagram, but this time I want you to include the networking information, the different subnets that we just figured out. So make it look, here, let me go on to the next slide. So make it look exactly like this with the routers and the switches, but rather than saying sales 14 hosts, I want you to say sales, and then I want you to tell me the subnet that is going to be in use here. So the subnet and the subnet mask in / notation. Do that for the 4 departments. Also do it for the point-to-point link. And another thing I want you to do is also put on the IP addresses that will be used on our router interfaces. For the router interfaces, use the first available host address in that particular subnet. Okay, so get your paper and pencil out. Go ahead and do that now. On the next slide, I'll show you the answer. Okay, so here we are with the answer. Remember when we did our design, we started off with the largest subnets, which was the engineering departments. So the way I would do my network diagram is I would show engineering in New York. That was 200.15.10.0/27. In Boston, 200.15.10.32/27. I've then got my sales department in New York, 200.15.10.64/28, and sales in Boston was 200.15.10.80/28. And the subnet I used for my point-to-point link, 200.15.10.96/30. Then we're going to use the first available address as the IP address on our router interfaces. So that was .1 on the interface on the New York Engineering Department, .33 for engineering, .65 for New York sales, .81 for Boston sales, and then the point-to-point link I'm using .97 on the left and .98 on the right. Okay, and this would be an acceptable network diagram in a real world environment. This is typical for how we would draft that up. Okay, that's it. So you now know how to do a variable length subnet mask design for a network. See you in the next lecture. Up to this point, we've done several examples of subnetting Class C networks, and hopefully you've got a good handle on that now. In this lecture, we're going to take it on a stage by subnetting larger networks. So we're going to look at subnetting our Class A and our Class B networks. So let's say for our first example that we've been allocated a Class B. The IP address is 135.15.0.0/16. That's our network address. And if we subnet that into /29 subnets, we're going to have 3 bits for host addressing, because we've got 32 bits in the address. 32 minus 29 gives us our 3 bits. And that will allow us 6 hosts per network, because 2 to the power of 3 is 248, minus our 2 gives us 6 hosts. At this point, we've done several examples of subnetting Class C networks, and hopefully you've got a good handle on that now. In this lecture, we're going to take it on a stage by subnetting larger networks. So we're going to look at subnetting our Class A and our Class B networks. So let's say for our first example that we've been allocated a Class B. The IP address is 135.15.0.0/16. That's our network address. And if we subnet that into /29 subnets, we're going to have 3 bits for host addressing, because we've got 32 bits in the address. 32 minus 29 gives us our 3 bits. And that will allow us 6 hosts per network, because 2 to the power of 3 is 248, minus our 2 gives us 6 hosts. So a /29, that's going to give us 6 available hosts per network, whether we're using a class A, B, or C. It's going to be the same for all of them. Here, because we were allocated a class B /16 range, we're going to have 13 bits for the network address. If it was a class C, we would only have 5 bits for the network address, because it's 24 to 29, a difference of 5, that would give us 5 bits. With a class B, we've got those extra 8 bits, so 5 plus 8 gives us the 13 bits. And that is going to allow a total of 8,192 subnets. Let's count that up as well. So 2 to the power of 13, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, and finally 13, 8192. For the IP address 135.15.10.138/29, what would be the network address, the broadcast address, and the range of valid IP addresses. Okay, you know the drill by now. Please pause the video, figure that out, and we'll come back with the answer. Okay, here's the answer. So the question was, IP address was 135.15.10.138/29. What's the network address, the broadcast address, and the range of valid IP addresses? We'll write this out the same way as usual. So we write out the IP address and the subnet mask. We put the line in after the /29, and the line is going in after the 8. You can see here, if you look up in the top right, that we've got ones under the 128 and the 8. So we add those two together. 128 plus 8 is 136. So the network address must be 135.15.10.136. The line is after the 8, so we add 8 to 136. The next network address would be 135.15.10.144. And if the next network address is 144, then the broadcast address must be 135.15.10.143. And the valid addresses for our hosts fall between the network address and the broadcast address. So that's 135.15.10.137 up to 142. Okay, another popular way of calculating the network address, the broadcast address, and the host addresses is by using the magic number method. You'll see this being cited in quite a few places on the internet. This one is very handy if you've been given the subnet mask in dotted decimal notation rather than with a slash. In that case, you can usually figure it out in your head. So a /29, if we wrote that out in dotted decimal notation, it's 255.255.255.248. And what you do with the magic number is you take the value in the octet that is being subnetted, so 248 in this case, you take that away from 256. So 256 minus 248 gives you 8, and you know that the network addresses are going to go up in blocks of 8. In our example, our address was 135.15.10.138. So we find which block of 8 is closest to that. So 10 times 8 is 80, another 5 times 8 would be 40, add the 80 and the 40 together, that gives us 120. The difference between 120 and 138 is 18, so 2 times 8 is 16, would give us 136. That's the closest value we get here, so the network address must be 136. And then we add the 8 to the 136 to get the 144 again, and we know that that is the next address block. Okay, so that's the magic number method. With the magic number method, just whatever the subnet mask is, you subtract that from 256, and that gives you your address blocks. It's pretty similar to the way that I was doing it previously. The way I normally do it is the octet that is being subnetted on, I'll write that out. So I'll write out 128, 64, 32, 16, and so on. And then I will figure out what the bit pattern is, and then I can put the line in, and I can see where the address block is at. But play around with this a bit, try out the different methods of doing it, and figure out which one you're most comfortable with, and that's one that you can use in practice and the one that you're going to use on exam day. Okay, let's move on to another example. So this example now will do a class A where we're going to subnet on the 4th octet. Previous example we just did was a class B on the 4th octet. This is going to be a class A on the 4th octet. And here we've been allocated 60.0.0.0/8. Same first question again. If we apply the subnet mask 255.255.255.240, so it's the same style of question but a different mask here. How many subnets do we have and how many hosts per network? So as usual, stop the video and I'll see you back in a second to give you the answer. Okay, so this example here, you see the other examples, we've been given the subnet mask as a slash notation. On the exam, maybe you'll be given it as a slash notation, maybe you'll be given it in dotted decimal. Here we were given it in dotted decimal, and we can figure out that 255.255.255.240, that is the same as a subnet mask of /28. Again, if you're not sure on it, you can just write it down. The more practice you get with these, though, you'll get really fast at doing it. Like if you look at the last octet there, 128 plus 64 is 192, plus 32 is 224, plus 16 is 240, plus 8 is 248, plus 4 is 252, plus 2 is 254, and plus 1 is 255. You see I was able to do that without even thinking about it. Once you've practiced this a little bit, you'll be doing exactly the same thing. So for our example, we had a /28, we put the line in, and we can see that we've got 4 bits for our host addressing. So that's 2, 4, 8, 16 minus 2 gives us 14 hosts per network. And now, because we were allocated a class A /8, we're going to have 20 bits for the network addresses, because the difference between the default /8 and the /28 that we're using is 20 bits. So 2 to the power of 20 works out at a little over 1 million subnets. Now hopefully you wouldn't have to figure out a number as big as that on the exam, but if you had to, you'd still be able to do it. Again, you just start at 2 and just keep doubling it up all the way until you've done it 20 times. As usual, we've got part 2 of the question. So for the IP address 60.15.10.75/28, What is the network address, the broadcast address, and the range of valid IP addresses? Pause the video and I'll see you back here with the answer. Okay, for this example, the line is after the 16 when we draw it out, so the network address is going to go up in multiples of 16. I can see by looking at the last octet of the address that I've got a 1 under the 64, and that's all. So the network address is going to be 60.15.10.64. And if I add 16 to that, the next network address will be 60.15.10.80. So our broadcast address here must be 60.15.10.79. And the range of valid host addresses fall between the network address and the broadcast address. So that's 60.15.10.65 up to 78. Another way you can do it is by using the magic number, and this is a way you can do it quite quickly in your head, especially if you were given the subnet mask in dotted decimal notation rather than in slash notation. But even if you have been given it in slash notation, you can still do it this way. You'll just need to convert it to dotted decimal first. So our example was a /28. And a /28, the subnet mask is going to be 255.255.255.240. We can figure that out by adding up the numbers. So a /28 is going to use the first 4 bits in the last octet. So 4 bits is going to pull to be 60.15. Let's do another example. So the previous example was a class A on the 4th octet. This time we're going to do a class A on the 3rd octet, and this one can get a little bit confusing, so you might need to pay attention to this one again. So in our example, we've been allocated class A 60.0.0.0/8. If we subnet it into /19 networks, how many subnets do we have and how many hosts per subnet? So pause the video again and figure out the answer, and I'll see you back here with the answer. Okay, /19 is, the line is going to be after 3 bits on the 3rd octet. So that leaves us 13 bits for hosts. 8 in the last octet, and then 5 on the right hand side of the 3rd octet. So to figure out how many hosts each network is going to support, it's 2 to the power of 13 minus 2. So that's 2, 4, 8, 16, 32, 64, 128, 256, 512, 1028, then 2048, 4096 and 8192 minus the 2 gives us 8,190 hosts per network. And because we were allocated a class A /8 range, the difference between a /8 and a /19 is going to be 11 bits. So to figure out how many networks we have, it's 2 to the power of 11. So we already know 2 to the power of 10 is 1024. So we'll double that again. That gives us 2048 subnets. As usual, we've got the second part to the question. So for the IP address 60.15.10.75/19, what's the network address, the broadcast address, and the range of valid IP addresses? Please pause the video as usual, and I'll see you back with the answer. Okay, this example we're subnetting on the 3rd octet. The other examples we've been subnetting on the 4th octet. The line is after the 32 on the 3rd octet, so the network block addresses are still going to go up in multiples of 32, but it's going to be on the 3rd octet rather than the 4th octet now. So our network address is 60.15.0.0. You can see it if you write out the whole IP address. Also, we're at 60.15.10, we're going up in multiples of 32, so obviously 10 is less than 32, so the network address must be 60.15.0.0. The next network address would be 60.15.32.0. So the broadcast address is going to be 1 less than that on the 3rd octet and 255 on the 4th octet. So the broadcast address is 60.15.31.255. And the valid host addresses will be between the networking address and the broadcast address, so that's 60.15.0.1 up to 60.15.31.254. Okay, so the value on the fourth octet is the lower range is going to be a 1, the higher range is going to be the 254 for the hosts. The subnetting is done on the third octet if the subnet mask is anything between a 16 and a 24. We can use the magic number method for that example again. It was a /19, so /19, that's 3 bits on the third octet, so that is 128, 192, and then 224. We subtract 224 from 256, which gives us 32, so that we know that the address block is going up in values of 32. Again, it's on the third octet rather than the fourth octet here. So we can figure out the same as we did in the previous slide from that it must be a network address of 60.15.0.0 because our value in the third octet is 10. The broadcast address, one less than that, 60.15.31.255. Valid host, 60.15.0.1 up to 60.15.31.254. Okay, review this example again if you're not sure about doing it on the third octet. Remember, we figure it out exactly the same way as we did when we were doing it on the fourth octet. So the address block is figured out exactly the same way again. You just need to remember that on the fourth octet, your hosts are going to go from 1 on the low end up to 254 on the high end. Okay, let's do one more example. So you've been asked to subnet the 134.65.0.0 network into 6 different networks. What subnet mask are you going to use? Please pause the video and figure out the answer. Okay, before I show you the answer on the next slide, let's see how we would figure this out. The network is 134.65.0.0, so we know it's a Class B network. And we need to split it into 6 networks, so we're going to need 3 bits because it's 2, 4, 8. It's a Class B, so the default subnet mask is a /16. We need 6 networks, which was 3 bits, so we add 3 to the /16, and that will give us a /19. So very easy to figure this one out. And that's showing it there with the line on our diagram as well. Some extra information that we weren't actually asked for in the question. /19 in dotted decimal is 255.255.224.0. The network addresses would be going up in blocks of 32. So 134.65.0.0, the next one 134.65.32.0, etc. And we would have 8,190 hosts in each subnet because we've got 13 bits available for the host address. 2 to the power of 13 minus 2 is 8190. Okay, so that's just done for all of the different examples of subnetting. Hopefully you're confident with this now. You should be. If you've worked through all of those examples, then you're going to be fine when you do the exam. When you are on the exam, there's lots of different ways that they can ask you questions about subnetting, but it's all going to boil down to just a few things, which you can see here. So it could be a variation of, given a network requirement of X amount of subnets and Y amount of hosts per subnet, what network address and subnet mask should you be using for each subnet? The other basic question they can ask is, if they give you a particular IP address and subnet mask, calculate that subnet's network address, the broadcast address, and the range of valid host IP addresses. So again, it could be any variation on those questions. They might ask it in a different way, but as long as you can answer those questions, which you can now because we've done loads of practice examples of them, you're going to be fine for anything that they throw at you on the exam. Okay, so that's our subnetting done. We've still got a bit more to talk about IP addressing though, starting with private addressing in the next lecture. In this lecture, you'll learn about the private address ranges. These were documented by the IETF, that's the Internet Engineering Task Force, in RFC 1918. RFC stands for Request for Comments. So when the IETF release some documentation, they release it as an RFC number, meaning that other engineers can comment on it and maybe suggest improvements. But the RFC is still a finished standard as well. So the final standard as of today for private IP addressing is RFC 1918. There are a load of other RFCs out there as well for pretty much every technology, but if you asked me to name an RFC number, then the only one that I probably could is RFC 1918 for private addresses. Because if you're in conversation with somebody, it's quite common to call it an RFC 1918 address. And money into converting IPv6. So
you.